we're going to check over your common denominator sheet looking to see which fraction is bigger. I'm sure with a lot of these you'll probably be able to already tell which one is bigger, but the main thing here is being able to find those common denominators. We'll use them a lot. We'll use them when we add fractions. We use them when we subtract fractions. So we got to make sure that we can do that. Basically what we're looking for is a number that 3 and 7 can both go into. Now we got a lot of choices, but it's easiest if you just take the smallest one. Later on when we do some reducing kind of things, the smaller the denominator you can find that works, the less work you have to do in the end. So I know that 3 is a factor of 21, 7 is a factor of 21, so I'm just going to use 21 as my bottom number. To get 3 to be 21, I multiplied it by 7. To keep this fraction the same, we've got to multiply the top and the bottom by the exact same thing. So if I multiply this by 7, it keeps the fraction the same at 1421. These fractions are equal. If I come down here, to get 7 to be 21, I just multiplied by 3, and then I need to times the top number by the exact same thing to keep the fraction the same. Because we're not trying to change the fraction any. We're trying to make it equal to each other. Okay? Not equal this way, but equal this way, with these two being the same. So we do 6 times 3, because we have to times it by the same thing, so that's going to be 18. Now that we have the same bottom number, it's really easy to compare. If I have something that's split into 21 pieces, and I have 14 of those pieces, and over here I have something split into 21 pieces, and I have 18 of those pieces, this fraction is clearly going to be bigger, which means that up here, this is bigger. Now you could have used a different denominator. I could see how different things could work. I could see if you did 2/3 and 6/7, maybe you use, I don't know, that's probably the most obvious one, but I know 42 will also work. I know that 7 times 6, so that would be times 6, so that would be 36. 3 times, let's see, what would that even be? 3 times 15 is 45, so it's got to be 3 times 14. So if we do times 14 and times 14, that's going to be 28, and again, doesn't matter how you do it, that one's still going to be bigger. Alright, I put this on here twice because I know that there's two ways that people are going to try to get this one accomplished here. A lot of people will probably go with 4 is a factor of 24, 6 is a factor of 24, so we go 24 at the bottom here. Some people are going to do 4 is a factor of 12 and 6 is a factor of 12, so we'll do 12 down here. Okay? Either way is fine, and actually you could use different things. I know you could use 48. There's a lot of things you can use as long as both 4 and 6 go into them, but we'll stick with these two because they're probably the most ones that people are going to come up with. Okay? Start with 24. To get 24, that would be 4 times 6, so we've got to times the top by the same thing. That would be 12. Okay? Over here, to get 6 to be 24, that's times 4, so I times the top by the same thing. 3 times 4 is 12. Those fractions are equal. So those fractions are equal. Okay? Now going to the other side, I mean, I'm already going to say when we do this, it's the same thing. We just use different denominators, so I already know that those are going to be equal, but let's just at least prove it here. 4 to get to 12 would be times 3, so 2 to get to 12 would be times 3, so that's going to be 6. 6 to get to 12 is going to be times 2, and 3 to get to, or 3, I just have to times it by the same thing as I multiply the bottom by. 3 times 2 is going to be 6. 12 24s, 6 12s, they're both equal, equal, equal. Alright, I put this on here 3 times because I could see probably some people coming up with some different things. Now this is an interesting one. The easiest way to do this is 5 is a factor of 20, and 20 is also a factor of 20, so we're just going to end up keeping this one exactly how it is. If you use 20, we can start like this. I can also see some people using 40. Okay, 20 is a factor of 40, 5 is a factor of 40, so that would work. Okay, and over here, something else, maybe you use, I don't know, you could have used 100. That's something that could work as well. Okay, they're both factors of 100. So let's go back through. If you didn't do this option, the chances are you probably did it right, as long as you multiply the top and the bottom by the same thing to get this. So we'll go through this, and if you have questions, if you did something different, you can just let me know. Okay, 5 to get to 20 would be times 4 times the top by the same thing. We get 16. 16 twentieths is bigger than 11 twentieths. So we can put that in there. Okay, down here, 5 to get to 40 would be times 8, and that's times 8. Okay, 4 times 8 is 32. 20 to get to 40 is just times 2. 11 times 2 is going to be 22. So that's bigger, more 40ths over here. And then if we change it to 100, I know that 5 times 20 is 100. So I'm going to times the top by 20. So that's going to be 4 times 20 is 80. 20 to get to 100 is times 5. So 11 times 5 is 55. And then again, bigger, bigger. All right, tree. A couple ways to do this one. The simplest way I can think is, I know 8 and 4 are both factors of 8. So this already has an 8 on the bottom, so I can just keep that. Over here, if I want to make that an 8, that would just be times by 2. And then we can multiply that by 2 as well. So we get 2 8s. 2 8s is equal to 2 8s, which means that 2 8s is also equal to 1/4. Okay? On this side of things, I could see people doing 32 as a factor. I could see that. That would work out well. I'm going to do 16 because it's the smaller one and probably easier to work with. I know that 8's a factor of 16. 4 is a factor of 16. 8 times 2 is 16. So I times the top by the same thing, and I'm going to get 4/16. Over here, 4 times 4 is 16. Times the top by the same thing. 4/16. 4/16 is equal. So that is equal as well. Alright, this time around we're rolling with two fractions that are both more than one whole, but it still works the same way. 3 and 6 factors. 3 goes into 6, 6 goes into 6, so that's probably the easiest thing to use. That would mean we could just keep that the same and we wouldn't have to do anything. Now this one we'll have to change a little bit. 3 to get to 6 would just be times 2. So I would times the top by 2 also. So that's going to be 18/6. 18/6 is bigger than 10/6, so I can do this, which means that is bigger as well. Always remember that if you change a fraction to an equal fraction, those are the same thing. They're the same fraction. We just changed it a little bit. Over here, I don't know, 3 and 6, I mean, you could use 12, you could use 18, you could use 24. 3 and 6 go into all those numbers. I'll just pick the smaller of the ones here. I'll go 12. Okay. 3 times 4 is 12. So I have to do 9 times 4, which is going to be 36. 6 to get to 12 would be times 2. 10 times 2 is going to be 20. So that's going to be bigger. That's going to be bigger. That's really all you need to know about having these common denominators. If you've got more questions, or you had different common denominators, you could have been right, but you just have to ask and find out.